Good morning, good evening, good afternoon, depending on where you are in the world. Thank you for joining me today at my workshop. We are going to be using Discord as a communications channel, and this is a live workshop. This is a live workshop, which means that I hope there will be some interaction. So if you are not on Discord yet, please join because I will not be monitoring YouTube chats or Twitch chats or wherever you're streaming this. It's going to be hard for me to keep track of all these things. So if you have any questions during the workshop, please feel free to just drop them in the Adversary Village general chat at the DEFCON Discord. The workbook will also be posted there as well. So you will need that URL in order for you to be able actually to follow along because the exercises are hosted on Gitbook. So you will need that URL. They are mentioned during the presentation as well. But it's going to be hard for you, of course, to just type that over from the slides. So please, once again, join the Discord if you're watching this live. It will be highly beneficial and it will make things a lot smoother and a lot more fun for both parties, actually. So without further ado, let's talk about what I'm going to talk about. So as you may or may not know, this workshop will be about C# and reflection. So of course, I'm going to disclose or talk about why I chose C#, what is reflection, and we're going to then create a loader, improve on that loader, and finally, to close things off, I will give my own personal view about the future of tradecraft. Note that I said my own personal view, so I'm not sponsored by anyone, or I'm not even like, it's not my employer's point of view, it's just my own personal point of view. So that being said, oh yeah, by the way, this is the link to the workbook, but I also linked it on Discord. I'm also just going to do like an emoji kind of thing on the URL that I posted. So if you hit that emoji, then at least I know some of you are paying attention or are actually watching this live. So if I see that counter going up, then that would be very nice. If not, then I know I can just continue. Cool. So I see some thumbs up already. That's very nice. So why C#? Well, throughout the years and as pen testing and red teaming evolved, well, most of you will probably know this, PowerShell was king, right? When defenses weren't as prevalent as they are now, PowerShell was definitely king, especially in the times before AMSI was even a thing. PowerShell was basically being used all over the place and is still actively being used today. You still have very, very popular command and control frameworks such as Empire, for example, that heavily leverage PowerShell. But as defenses improved, so did malware and so did our adversarial mindset and our adversarial tradecraft as well. We had to level up to follow suit with the defenses that were in place. So when PowerShell became more and more scrutinized and became under heavy fire from things like AMSI, things like constrained language mode, things like deep script block logging and stuff like that, we started looking for a replacement, right? And we found that replacement in C#. And why C#? Well, PowerShell was king, but when defenses became better, PowerShell kind of dropped from the throne, right? It's still very much alive, but it kind of fell down a few places, a few steps from heaven. So PowerShell actually in the backend uses the Microsoft.NET framework, and there are other languages that utilize that .NET framework in the backend as well, such as Iron Python, Iron Ruby, Boo language as well. And big shout out to Marcello, aka Bytebleeder. I think he's probably more known for being Bytebleeder than for being Marcello. He created a C2 framework called Silent Trinity, which kind of incorporates or values or embodies the bring your own interpreter kind of methodology, which can, for example, use Iron Python, Iron Ruby, or Boo, for example. But there is also a native language that is installed in most modern Windows distributions, and that's actually the .NET framework. And the .NET framework, of course, also has C#, which is, well, being able to be used basically without scrutiny. Well, nowadays, of course, there is scrutiny because AMSI got introduced as well in the C# framework. But there was a sweet spot. There was a time where PowerShell had AMSI implemented, but C# didn't yet. So that's why a lot of tradecraft actually started porting over from PowerShell to C#, because there is a lot of interoperability there, as PowerShell in the backend uses .NET Framework, C# in the backend uses .NET Framework. So it was not that hard to take existing tradecraft and port that over to C#. Right. So what is reflection? I basically Googled it. I have 3 definitions here. I'm not going to read them out loud, or I'll probably still be here tomorrow. So it all boils down basically to dynamically creating an instance of a type and invoking its methods. Now, what does that mean in C# specifically? It means that C# is actually capable of creating an assembly, so an executable, which is able to load another executable into the executable. So it's basically inception, right? You have an executable and you load another executable in that executable and execute functions from the new executable. Right. If that sounds a bit nuts, or if that doesn't really make a lot of sense, don't worry about it. We're going to see how it works in just a minute. That's kind of the whole point of this workshop. So without further ado, let's meet our first loader. You will see a lot of Dragon Ball Z analogies here. I was originally planning on giving this workshop with a lot of World of Warcraft analogies. I already had everything lined up, but then we all probably saw the news with Activision and Blizzard and the lawsuits that were going on and the negative press. So I made the rash decision to refactor all my code and to port everything over from World of Warcraft references to Dragon Ball Z references. So without further ado, meet our first loader. It's Raditz. This is a bit of the proof of concept stage. So what is the assembly actually going to do? We're going to create a program which simply will load another program into the memory and execute it, but that program will need to live on the same computer system as the program is run. So we're not going to do any fancy things yet, like doing things over the internet. We're just going to stay on disk. So you need the 2 programs on disk, the one that will load the program and the program you want loaded need to be on the same computer system in order to load it correctly, at least in this stage. Of course, we will improve upon that as the workshop improves. So this is the first loader, but in order to start doing this, of course, there are some prerequisites. You will need a virtual machine. Well, you could potentially do this on your live machine as well, if you're brave enough, but I would recommend a virtual machine with Visual Studio installed, with .NET Framework installed, and preferably with a web server as well, which is why I asked ABX to share the link of the Gitbook pre-workshop, because Lab 0 is actually the setup lab. So I hope that some of you already have done the Lab 0, basically, which is the setup, getting everything ready. If not, please do so now, while I will go over the codes, basically, of Raditz and explain how that works. Because after my explanation of the code, it will actually be your game. So it will be a very hands-on workshop. This is why I wanted to give it live, so I can answer any questions that are being asked like dynamically in real time. Pre-recording this format wouldn't really make a lot of sense. So this is Raditz. How does it look like in code? This is nothing very fancy. As I said, this is the proof of concept stage. This is just to grasp what reflection is all about. So we have our program. It has 1 function. Well, technically it has 2. It has a main function and a reflect function. The reflect function has 1 argument, which is a string called file path. And we're basically going to use the assembly. We're going to call it .NET program, and we're going to use the assembly class in .NET and the load file function of that assembly class, which takes coincidentally 1 argument, which will be the file path argument. Then we are going to prepare our arguments that we're going to pass it, even though this example doesn't require any hard arguments. We're still going to need to pass arguments, because we're going to be calling the main function of this hello reflection world executable. And as you can see here on the slides, the static void main, the main methods of an executable by default has an argument or requires an argument, which is a string array that they call arguments. So here you can see that we are preparing arguments, even though it's an empty array. So we say an object array parameters, which is actually just a string array containing nothing or null. And we are going to then invoke the entry point of our new program. So hello reflection world.exe. We're going to invoke it on its entry point. The entry point will be the main function, and we're going to pass it these parameters, which is basically nothing. So the only thing it will do is it will call the hello reflection world executable, and it will just print to console hello from reflection world. So nothing too fancy there, but that's just to have the basic concepts of how reflection works. So I'm going to give you now about 10 minutes to make the hello reflection world. Well, I'm going to give you 15 minutes. So 15 minutes to build the hello reflection world assembly and to build your first loader. So basically the Reddit loader. I'm going to link the Git book once again in case you haven't joined the Discord yet and you have joined just now. I'm going to link it one more time. So that is the manual basically that we're going to use throughout this workshop. And I'm going to expect that you finish lab 0, lab 1, and lab 2 basically in the next 15 minutes, because lab 0 should have already been done prior to joining this workshop. So I will be posting in Discord finished exercise 1, which is basically lab 1 and 2. So if you're done, just hit a thumbs up on the Discord so I know that you're done and I know when to move on, basically. All right, so I will talk to you all in about 15 minutes then. So in case, by the way, in case you have any questions, feel free to let me know. I will answer them. That's why we do a live workshop. I'm not currently in the voice channel though, because I don't want to hear like 20 people shouting in my ears while I'm talking. So please, during the workshop, if you have questions, ask them via text in the Adversary Village general channel. After the workshop, I will join the voice channel as well, so I can, well, talk to you and meet all of you after the workshop. But during the workshop, if you have any questions, just type them out, please, as it makes it easier for me to keep track of all these things. I actually see that a lot of people already have their thumbs up. So I guess I have some very proactive people in the workshop. So I guess I'm actually going to cut this a little bit short in order to give you some more time in the more complex exercises, as this was just a very basic proof of concept. So let me talk about the obvious and some non-obvious flaws in the Reddit loader. So the most obvious flaw here is that we have no way of remotely fetching the assembly just yet. So that means that from an operational point of view, this loader doesn't really make a lot of sense, right? Because you would still have to drop your original executable that you want to that you want to execute on disk as well. So there's not really a lot of usage of this very basic loader. So we're going to try and fix that. And then we have stuff like MZ and ETW to worry about. So if you're not familiar with MZ or ETW, allow me to take some time to explain those concepts to you right now. So MC is basically anti-malware scanning interface. It's a vendor agnostic kind of, well, framework, I would say. It's maybe not the best word, but it's like an engine released by Microsoft themselves. They are properly documented as well in the Microsoft documentation. So it's an open to use scanning engine that any antivirus vendor or EDR could leverage if they want to, without having to pay Microsoft any licensing costs or any fees. So if your EDR or antivirus is not leveraging MC, then I would suggest looking into maybe some other EDR or antiviruses. I'm not going to say that an EDR or an antivirus solution should always rely on MC, but I mean, it's there, it's free, so why not just utilize it? Microsoft invented it for a reason. Of course, it has its flaws. It can be bypassed. We're going to talk about that later, but at least there will be some additional overhead, or we are going to quote unquote increase the costs for an adversary to try and penetrate your network, basically. So we still have MC to worry about because MC will block anything that it finds malicious, that it deems malicious. It will block it from executing. We still got ETW to worry about as well. ETW stands for Event Tracing for Windows. And that one is a bit harder to explain in layman terms, but the most high level explanation I can probably provide you for ETW is that it's doing kernel level tracing. So it is something that is living on your Windows system on kernel level. So it's not really something that adversaries, unless they have kernel read-write permissions, can tamper with that easily. However, you can still tamper with it from a user mode as well, as we're going to see, but we're not going to be able to fully disable ETW, like completely butcher it. We're only going to be able to temporarily mute it for our own process. And what ETW does, it has a lot of very different providers, one of which is .NET, and EDRs and antivirus solutions can tap into those providers, so those ETW providers, to keep track of things that you're trying to load. And one of the best examples, or the most tangible example that I can find without having to go really in depth in how ETW works, is by simply using Process Hacker 2 to inspect your assembly. Process Hacker 2 has a nice tab called .NET Assemblies. And if you would check Reddit, for example, then go to the .NET Assemblies, you will see here that you have two app domains, one shared domain and one app domain called reddits.exe. And you'll see that the Hello Reflection World Assembly is actually loaded into that domain as well. And this is the location of that assembly. So you can see it here. So that's what ETW does. And that means that, for example, imagine that an EDR is tapped into those providers as well. You try to load Bloodhound, for example, which is a very well-known .NET assembly to do domain recon. It will show up in the provider. It will show Bloodhound. It will also show you what method exactly was trying to get invoked. So it's very beneficial, and from an offensive point of view, to disable this. So basically you have MC and ETW to worry about. Does that make sense for everyone? You can just type in the general chat. I'm monitoring it, so it's a lot of fun for me if there is some class interaction. So am I making sense so far? If everyone is just very silent, then I will just assume that I'm making sense. Right. Awesome. So let's talk about Nappa for a minute. Nappa is our second loader, so it's going to be an extension of our Reddit's loader. And as you can see, we're staying in the Dragon Ball Z analogy. So if you are a fan of Dragon Ball Z or you do get the analogies, Reddit's is one of the first villains. I'm not going to say it is the first villain because you have a whole bunch of villains before Dragon Ball Z actually starts. So Reddit's is one of the first villains that Goku encounters or hero in Dragon Ball Z, basically. And Raditz is one of the second adversaries that he faces. So it increases, like the villains increase in power level and strength. So that's why I'm basically going into the chronological order of Dragon Ball Z villains. So here we are introducing a web angle, which basically means that the C# assembly that we are going to use, something over 9,000 hood rate, yeah, exactly. The assembly that we're going to use to load our remote assembly, we're still going to drop that on disk. During this workshop, we're always going to drop it on disk. Of course, if you're using Cobalt Strike, for example, or another framework that is capable of doing CLR injection on the fly, you could potentially just do this entirely in memory as well. But that is a bit out of scope of this workshop. So the loaders themselves will always be dropped on disk for this workshop at least. So in this case, we have our loader on disk, and we're going to reflectively load over a web resource. So what does that look like? Well, we're going to introduce a new function called reflect from web. Still only takes one parameter, so it's a string again, but this time it doesn't expect a file path, it is expecting a URL instead. So what we're going to do here is we're going to use the web client class in .NET. We're going to call that client. We're going to instantiate a new web client from that class using the constructor. So new web client, we call it client. We will define a new byte array called program bytes. And we're going to use the web client.download data function, which takes one parameter, a URL, which we specify in our reflect from web. So it's going to fetch that data as a byte array. Then we can use the assembly.load. So note the difference here. It's not assembly.load file anymore. So it's a very nuanced difference there. We're now using assembly.load instead, and we're defining, or we're pointing it to our byte array program bytes parameter or function that we just specified. Still, we're going to define the empty string array as we're going to try and invoke the main method. And that is going to be it for the Nappa loader. So here we are introducing fetching from web. There are some things that we still can improve upon, of course. Otherwise, this workshop would be very short. Obviously, I will dive into the shortcomings of Nappa as well. But I'm first going to give you about 10 minutes again to basically implement Nappa. So that would be lab 3, creating the Nappa loader on the Git book. So once again, I'm going to type finished with exercise 2, which is lab 3. Well, that could be confusing. I'm just going to type finished with lab 3. Once again, with a thumbs up emoji. So hit that thumbs up if you're done. Then I know that I can just proceed with the workshop. If there are any questions, do let me know, of course. I'm still here. It's interactive. They gave me, Adversary Village was kind enough to give me the option to do a pre-recording. I didn't want to do it because, well, I want to have that interaction, of course. It doesn't really make a lot of sense for me, at least, to have a workshop pre-recorded because then you lack the student interaction. I see a question from Xotria. Sorry if I totally butchered your name. I really apologize. Once the payload is loaded reflectively, can we unload and replace it? Would be nice if our implant can be hotfixed. Well, I'm gonna let you in a little secret. Yes, it can. And we're going to see that when we're talking about Lab 7, which will be creating Cell. So yeah, you'll see how you'll be able to unload binaries, basically, reflectively. All right, I see some thumbs up already flying in. That's nice. I'm just going to wait again until it's like 7 thumbs up, as that seems to be the best number to wait upon. It's lucky number 7, right? It's DEF CON for a reason. So just as a reminder, because it's kind of weird to just have this awkward silence, we're doing lab 3 right now. If you're done, just hit that thumbs up on the finished lab 3 in Discord, so I know you're done and I can move on to the next section of the workshop, basically. Right, 7 thumbs up. That's what I like to see. So now we have seen how to reflectively load on disk. We have kind of seen how to reflectively load over the web as well, but there's obviously still a big flaw. What happens if we 404? And more importantly, what about HTTPS? Because right now we're just fetching an assembly over HTTP. It's not really that OPSEC safe, right? We like that HTTPS going, so we still don't do that. We still don't really have any error handling as well, so we do have to deal with that 404. If the assembly isn't found, then our loader will just crash. That's not that nice. So 404, well, guess what? Worked fine in dev. It's an ops problem now. Obviously, that's just an insider joke there. But let's see how we can potentially fix that. So we still have to deal with MC and ETW as well. Here you can see Napa very nicely smiling at us. Hello, Reflection World. Still very nicely smiling at us as well. So now we have to introduce Frieza. And if you know some Dragon Ball Z analogies, you'll know that I skipped Vegeta. Why do I skip Vegeta? Well, because Vegeta isn't really a villain, right? He turned to be one of the good guys. So I'm going to skip Vegeta for now. So I skipped Vegeta and straight up jumped to Frieza instead. So now we are going to expand or reflect from web error, and we're going to poll until a 404 is being, it's not being presented anymore, or the retry limit is hit. So what does that look like? Well, very simple. We will try fetch the assembly. If it doesn't work, we're going to try again until either the assembly is found or until our retry limit stops. So if it's go below 0. So what does that look like? Well, we're going to expand or reflect from web with 2 additional parameters. So one will be the retry count, one will be a timeout timer. They are both going to be integers. So that means that they're both going to be numbers, non-decimals, so integers basically. And of course, the string URL is still going to be there. We also deal with HTTPS by allowing TLS 1.2 to be supported using the service point manager.security protocol. There are other encryption types as well, obviously, that are supported. You can just take a look in the Microsoft documentation, service point manager.security protocol, and you'll see the different enumerations that you can do. I found to have most success with TLS 1.2, just works most of the time. Web client, new web client, well, it's still very much the same as we already had. The bytes, still very much the same. But now we're going to introduce a loop. So now we have a while loop that says, while the retry count is bigger than or equals to 0, and the program bytes are basically non-existent, so null, we're going to try and fetch the data. If we can't fetch the data, well, then the web client will actually throw a web exception. So we're going to catch that web exception. We're going to say, okay, look, the assembly isn't found yet. We're going to sleep for the specific amount of time that we identified during the timeout timer here, and retry for another, retry count. And we're going to, of course, decrement the retry count by 1 and go to sleep for the timeout timer times 1000, because the timeout timer itself, so the sleep function takes milliseconds, and we want to have a seconds instead. So that's why we do times 1000. If that whole while loop doesn't yield any results, so imagine that we hit our retry count, it goes below 0, we still don't have any program bytes, then we don't want to crash our program, so we're going to have some robust error handling here. So if the while loop still doesn't yield any results, we're just going to say, okay, assembly was not found, we're going to exit now. If it has been found, however, we're still just going to do the same thing. So we're going to load our assembly. We're still going to give it the parameters that it expects for the main function, which is just an empty string array saying null. And we're going to invoke it. So we're going to actually reflectively load it. So this is starting to get a little bit more complex. So I hope that my explanation was adequate. If not, feel free to ask questions. because now it's your guys' turn. Well, guys and girls, of course, I don't discriminate. So you can go ahead and do lab 4, creating the Frieza loader. I estimate that it's probably going to take you about 10 to 15 minutes again, because it seems that people are thumbing up quite fast. So I guess that most of the attendees are somewhat experienced with C Sharp. But then again, if you have questions, do feel free to reach out, of course. Once again, I'm going to type finished with lab 4. Just do the thumbs up thing if you're done, so I know when to when to go ahead with the workshop. Steve-O, thank you very much. If you would be the Steve-O from Jackass, that would be pretty amazing. I guess it's not you, but Redman asks a question. Will we be able to still access your Git book page when the lab contents, with lab contents after DEF CON? Yeah, I do plan on keeping it up. However, I don't have an SLA, right? So no guarantees on when it will eventually disappear again, but I'm not planning to take it down for the foreseeable future, at least. Yeah, that's an excellent remark as well, Steve-O. You can download it as a PDF. I do have a export to PDF functionality out there as well. Shout out to Valkan, by the way. Nice to see you're here, that you could make it. So I see that Rasta Mouse is having some problems getting into the chat. So Rasta, if you if you want to come hang out at the Adversary Village Discord chat, there's actually, you have to go to roles basically in DEF CON. So in the DEF CON Discord channel, there is a sub channel called roles, and you'll have to click the house button there to get the role that will allow you to access the side villages as well, which Adversary Village is one of. So if you do that, you'll be able to troll me basically. Knowing Rasta, I'm pretty sure he won't be he won't be showing up in the Adversary Village channel because it's too much of a hassle to get in. But don't worry, Rasta. Don't worry. I have you with me at all times, right? I still have the Rasta plush to flex. You know, I like to show it off. So does it make sense for everyone up until this point? As I do have some dead time to fill, it's always nice to hear from the students that may already have finished the lab. Zarak, why add this service point manager at this step? Well, it's because in the next loader, we're actually going to start fetching things from GitHub, which uses HTTPS. So that's why we are getting rid of the HTTPS problem in this loader already, just to set it up for the next one. Well, it doesn't just add the capability to use an HTTPS URL. It also adds the capability to have a retry loop, basically, up until the point that it finds the assembly. And the reason why I am implementing this is because it will make sense when I talk about the future of tradecraft. So this, at the end of this workshop, you will not have an out-of-the-box solution to bypass modern EDR defenses. That's not really the scope of this talk. It's more about an introduction to C# and then the introduction to reflection. But I will give you some hints, or this could potentially be stepping stones for you to build further upon. And you could potentially build a whole CI/CD framework using this as a baseline. But it all starts to make sense at the end of the presentation when I talk about the future of tradecraft, basically. Yeah, no worries. I see 6 thumbs up for lab 4. Just going to wait on one more thumbs up. Then I can continue. That was incredibly fast. All right, awesome. So now we have the flaw in Frieza with the 404. We basically got it fixed. So we don't have to worry about the 404 anymore. We don't have to worry about HTTPS anymore. But of course, we still have to deal with MC. We still have to deal with ETW. So now we have reached a bit of a crossroads. And why have we reached a bit of a crossroads? Well, it's because we now have to choose, like from a design perspective, whether or not we're going to start building in MC and ETW bypasses into our loader, so hard-coded into our basic loader, or if we are going to leverage reflection to load these bypasses and then do another reflection to load the assembly that we're actually targeting. So basically, we're going to be double reflectioning away at this point. So you have the option. You could prevent this, and you could just say, okay, I want a built-in MC bypass, a built-in ETW bypass. The thing is, at least in this workshop, we're still under the assumption that you're going to drop this to disk. Obviously, this is not very OPSEC safe, but just to make this as accessible as possible and not go into the details of running .NET completely in memory. So I kind of want to avoid having to explain how to inject the CLR dynamically, So we're just assuming for this workshop that we're going to drop this to disk. If you drop a .NET assembly to disk, it's very prone on getting reverse engineered. So the bypass, of course, will just be seen straight away. People will see immediately that something fishy is going on. Also, if your bypass gets detected, well, guess what? From the moment you drop your assembly to disk, because your bypass is detected, your assembly is going to trigger MC, of course. So that's why, from my perspective, or at least my preference, is to remotely fetch a bypass instead of just hard coding it. I hope that makes sense, but I just want to show you that it is possible, of course, to just build it in as well. It's kind of like a design choice where I choose to load things reflectively, so the bypasses as well. So double rainbow, I mean reflection. What does it mean? Well, again, we're just going to do the poll until 404 is not there anymore. So poll until we finally fetch our assembly or until our retry limit is hit. We're going to reflectively load the ETW and the MC patch into our loader. We're going to execute that. Once these things are taken care of, then we're going to once again send out a new web request to actually load the assembly that we want to load. And once this is done successfully, we basically thwarted the defenses that are on a modern system. Of course, not taking into account, EDRs, right? Because this will not fly in an EDR world. Well, at least not straight out of the box without any prior modifications. So what does that look like? Well, pre-MC patch, if you would start the Frieza loader, which is it's going to fetch Rubius from Flangvic's Sharp collection. If you're not familiar with Sharp collection from Flangvic, it's basically just pre-compiled assemblies already available to you. Now it's up to you whether or not you trust Malvin or Flangvic to not have injected some malware into this, but he seems like a straight up guy, and you should be using a VM for this workshop. So let's just assume that the Rubius version pre-compiled in the Sharp collection is clean and is indeed just Rubius without any other malicious things added to that. So if you would try to load that straight off the bat with MC enabled, then you're going to face this very non-descriptive error. Also worth noting, it's not going to, at least from my testing, it's not going to show you that classical AMSI, like a virus was detected or something. It's not going to pop up. It's just going to block it, and it's going to remain mute. So it is going to do its job. It is going to block your assembly from being reflectively loaded, but it's not going to give you that pop-up saying, a malicious thing was detected on your computer. So that's already something worth noting that might be interesting to you. And obviously, pre-ETW patch, you're going to see, so imagine that you just bypass AMSI but not ETW. Well, then Rubius will be in your app domain, basically, and it will just stick out as a sore thumb as well. So any antivirus solution on EDR subscribing to your ETW provider that is keeping track of assembly names would basically see that you are trying to load Rubius. So with that said, if you would use the double loading, so if you would load our MC and ETW bypass, what's going to happen is you're going to load the MC and ETW bypass. You're going to hit a key to start the evasion. It will evade MC. No, it will first evade ETW. So it's going to patch ETW first before patching MC. Why? Because if you patch ETW first, then ETW is not going to see the MC patch anymore. So you're going to patch ETW first, then you're going to patch MC, then you're finally getting the Rubius assembly. And I did update it because Rubius obviously got a very nice overhaul. If you haven't seen the talk of the Spectrum guys at DEF CON about the ADCF stuff, so the certificates in Active Directory, I highly recommend watching that. So it is Rubius version 2.0.0. As you can see here, Defender's basic vanilla Defender is turned on, so no EDR, but just basic Defender is turned on, but it doesn't have any problems in loading Rubius anymore. And if we would check our .NET assemblies in Process Hacker, you're going to see that it's actually unable to start the event tracing session because we patched ETW's event rights for our current process. So it's actually not passing any data anymore to the provider. So it's untrackable, well, quote unquote, untrackable. If that all makes sense and there are no questions, I would suggest that you do lab 5, which is probably the most interesting one from an offensive point of view, at least, as you could potentially use this immediately into operations, as this is just going to patch MZ and ETW for you. I estimate that this one will probably take you about 15 minutes because it's a bit more complex as you're doing some in-memory patching, basically. So I'm going to once again do the finished with lab 5 in Discord with a thumbs up. Wait until I see 7 thumbs up before I proceed with the next section of the workshop. If you're done with lab 5, by the way, and if there are no specific questions about the MZ or ETW bypass, then go ahead and also do lab 6 already as well, which is going to tie it all together basically and will allow you to modify Frieza to to leverage the MZ and ETW executable that we just created in lab 5 and load that first before then starting with loading Rubius in memory as well as a proof of concept. So for the people that have already finished, how do you like the workshop so far? Any questions? Be evil or Beevil, not sure how I should call you, asks, is there some kind of size limit for payload loading? That's an excellent question. And to be frank, or to be fair, I don't really know. I didn't have any issues yet with loading some bigger assemblies. So, for example, if you would execute assembly in Cobalt Strike, I know you would have those size constraints of 1 megabyte, for example. But with this assembly.load, basically, so the reflection capabilities themselves, I have yet to encounter problems with size constraints. I'm not going to put my hand in the fire and say there are none, but at least from my testing, I haven't encountered any major issues yet with size constraints. So I would owe you the answer, Be Evil. I'm not 100% sure, to be honest. Redman says, workshop is great. I like that you didn't pre-record. Thank you for putting this together. Just started to dabble in C Sharp. Well, there you go, Redman. You're welcome. It's for people like you that I put together this workshop. It's basically meant to be an entry point or starting point to C Sharp, trying to give you some tooling, some insights on how specific things work, and lay the foundations so you can build upon that further if you want to. Right, I'm going to give everyone about 5 more minutes to finish up this exercise before going to cell, which is our next loader, basically. All right. I see that dude, man, bro, is typing something, so I'm just gonna wait until he finishes up whatever he was typing. I guess nothing because it disappeared. So now we have seen how to reflectively load on disk. We have seen how to reflectively load over the internet from HTTP, from HTTPS. We even put some robustness into there, trying to fetch the assembly over and over until either the retry count goes below zero, or if we actually find our assembly. We also learned how to bypass MC, how to bypass ETW. But what we haven't discussed so far is how to build and tear down assemblies as we load them. That was one of the questions that was asked almost at the beginning of the workshop. So I'm going to tell you about Cell. And Cell is actually created not really because we're going to add a lot of new functionality in there or any real cool shenanigans, but to explain the concept of application domains. So application domains or app domains is something pretty cool. It's basically allows you to have an abstraction layer in .NET, like you would have when two processes are talking to each other as well. So you would have a process. A process has a virtual address space, and another process would have its own virtual address space, and those would be separate, right? So you wouldn't really share a virtual address space among different processes. Well, the same thing is kind of here with C# with app domains. So what you can do is you can have an assembly. You can create a new app domain in there, do stuff in that app domain, and after you're done with it, you can just discard that app domain or keep it alive, and add as many app domains as you want. You can have like 20 or 30 app domains. You can discard them whenever you want, basically at runtime. So that allows you to have one implant or one loader, and which is capable of loading an assembly, and then after the assembly has run, tear it down again. So completely throw it away back. So it's not really in the memory of that program anymore. So what does that look like? Well, I'm going to create a new inner class here in C# called worker. Basically, this enables access to objects across application domain boundaries in applications that support remoting. This is not something I invented. This is actually something that is just straight out of the Microsoft documentation. So if you would look for application domains on the MSDN, so the online documentation that Microsoft put out there, you're going to find an example on what you can do and how you can use it, which is following the same exact pattern. So also creating that inner class, so the inner worker class. And what we're going to do here, so once we create that inner worker class, we're going to actually migrate what we want to do into the new inner class. So instead of having it into our program, we're actually going to shove it or replace it by shifting it up to the worker class. You'll see it if you have the Git book open. You'll actually see that with the full code. So the reflect from web function will not live anymore in the class program. It will now actually reside in the public class worker instead, which allows us to actually have the main function, so the main function of the program class, which allows us to actually have a new app domain, which we call Namek in this case. So we're going to create a new app domain called Namek. Then we are going to instantiate that new inner class, so that worker class. We're going to call it remote worker. And then we can do the app domain dot create instance and unwrap to basically have a the reflection capabilities of the assembly that we're going to load. So in this specific case, we're going to do the reflect from web to have our hello reflection world into the memory. But instead of having it into the main app domain, we're actually going to have it in the app domain of Namek, which we can then discard after we have successfully loaded our hello reflection world executable. So once that is done, we can simply unload the entire app domain, which will remove the hello reflection world from our memory. Then we could, for example, create a new application domain. This is all at runtime, so we're not going to restart the application or anything. So we're going to create a new application domain, in this case, Snakeway, and then we're going to have our MC and ETW bypass and the Rubius thing that we just did using our previous loader. So we're just going to do exactly the same, but this time we're going to use app domains for that, to have that separation and to have that flexibility to unload it whenever we don't need that specific application anymore. So what does that look like? If that was a bit fuzzy or a bit too technical, hopefully this will clear it up a little bit. So here you can see that we run our cell loader. We're going to have that app domain Namek. We're going to reflectively load our hello reflection world. And as you can see here, when we inspect our assembly, you can actually see that we have our app domain cell.exe, which is our main app domain, if you will. And in that we actually have a new app domain here as well called Namek, which obviously has our cell executable, but also has our hello reflection world. So instead of loading it into our main app domain, we load it in Namek, which gives us the extensibility to unload it as well. Because in the next step, we're actually going to unload Namek. We're going to create a new app domain called Snakeway. And as you can see here, in the real-time tracing, basically, there's no trace left anymore of Namek, right? It's completely thrown away, so it's completely unloaded, and it got replaced by Snakeway, which has our MS Core Lib, which is the name we gave to our MC and ETW bypass, still in here up until the point, of course, that you start using the MC and ETW patches, because then it will stop the tracing, of course, and that will be the last thing that ETW will see. So does that make a little bit of sense? Because this is probably the most complex topic of the entire workshop, even though the implementation itself is just a few lines of code. So if you don't have any questions about this specifically, please go ahead and do lab number 7, which is creating cell. If you do have questions, obviously feel free to ask them in the Adversary General chat of the Adversary Village on the DEF CON Discord. I'm still there to monitor for questions and to answer them for you. So once again, I'm going to type the completed lab 7. If you have done so, just give it a thumbs up so I know that it's done, because that's actually almost the end of the workshop. We're then going to close down with some brief notes about me rambling on how you can potentially use this knowledge to create some cool pipeline if you want to. We're also going to discuss briefly the future of tradecraft, or at least my opinion of the future of tradecraft. So yeah, go ahead and finish up lab 7. Have fun, and that will be the last exercise of today. Unless you really are in the zone and want to do the bonus lab as well, feel free to do so. There's no cuts. Like solution for that one. I deliberately, obviously, I have the solution, but I deliberately didn't include it into the Git book because I want you to take some time, do some additional research yourselves if you are interested in C# and you want to learn more, because that will, that will level up your skills basically. That is an excellent question, Zarek. So the bypasses we're loading here are they app domain specific. So for each new app domain we create, we'll need to execute MS Core Lib for the bypasses. Actually, no, Zarek, that is not the case. So if you execute it once in a specific app domain, it's going to bypass MC and ETW for the entire process. So it's not app domain specific. It will bypass for the entire process. It's an excellent question, which I forgot to mention, so thank you. Oh my God, Rastamouse, you made it. Nice, because I'm going to reference you in just 2 slides, I think. No, 5 slides, sorry, 5 slides. In 5 slides, you'll show up. So, Rostamaus, you promised some jokes, right? During the breaks. I mean, you did say you were going to troll, so now I'm putting you on the spot, right? No problem, dude. No problem. Let's just start from the top. Yeah, of course, ABX. After the workshop, I'll be heading down to the Q&A for some voice chats. No worries there at all. I don't know if Rostamaus will join, though. I hear he's a bit shy. Just kidding, of course. Maybe I can do one very lame joke because now Rostamaus actually made it. So I feel like I should probably just do a joke. It's not really Rostamaus related, but just in celebration that he actually made it to the Discord channel. So why do Java developers wear glasses? Why do Java developers wear glasses? Because they can't see sharp. Tadum-ts. Thank you. Thank you. Please hold your applause. ABX because they can't see sharp. Yeah, I know. I got more where that came from as well. Should I do one more while we all wait until some people finish up the lab? So why do astronauts use Linux as an operating system? Why do astronauts use Linux as an operating system? Because they can't open windows in space. Well, ABX, you say, I would say adversary jokes, but I only know one adversary joke, and it's a rather lame one, to be honest. But if you want, I can tell it. It's no problem. If you want to hear the lame adversary joke, then yeah, I can do it. So where did the adversary go? Where did the adversary go? He ran somewhere. Sotiria, by the way, all we have done here is loading whole assembly from external files. Is it possible to load a portion of code instead of the whole assembly? Kind of like loading shellcode in native land. Uh, Not 100% sure what you mean by that. But yeah, of course you can do shellcode injection and all that kind of good shenanigans as well in C Sharp. And yes, you can load modules as well. You can do manual mapping. If that is what you mean, yeah, you can do that. Right. So yeah, be evil. Is it still viable versus EDR? No. As I already mentioned a few times, I'm not going to give you out of the box EDR evasion capabilities here. I'm just basically giving you building blocks in order for you to do some more research on and further expand upon to actually start evading EDRs. If you do want to hear me talk about using C Sharp to defeat EDRs, there are some YouTube talks available already where I talk about that kind of stuff. I'm going to be giving that talk again at BrewCon later this year as well. So if that is more up your alley, then feel free to search for that or wait until I do it again at BrewCon. Right. That being said, let's just go to the final section of the presentation, and then we have some more Q&A coming up as well after that. So let me see how many thumbs up I've gotten so far. Only 3, but I assume that more people have finished lab 7 already, or at least I hope so. right? If you haven't finished Lab 7 yet, not to worry. You'll have plenty of time, but I'm just going to close it down with some closing thoughts and some potential future of tradecraft. So what else can you do in order to try and be even more OPSEC or do some more research or expand upon these buildings blocks that I just provided you? Well, we haven't really looked into any obfuscation and we haven't really looked at any encryption either. So start obfuscating binaries, start doing some encryption and decryption at runtime could very well help you in potentially even bypassing EDRs as well. Probably for EDR evasion, you'd have to do some unhooking as well, depending on what you're trying to achieve. But other than that, those two areas are not really covered in this workshop, as they would probably get a bit too complex for people that have never played around with C# before or have very little coding experience. So that is why I deliberately excluded them from this workshop, but definitely worth looking into if you try or if you want to start using what I basically showed you during this entire workshop operationally, then that would definitely be two avenues to be worth exploring. Then some like a potential implementation of this technique is like this. So for example, you compromise the system here, right? And you have a .NET assembly basically running in the background. And what you have here is a endpoint, a web endpoint with an API, like a REST API, for example, which is fired well off or probably even hardened with some specific user agent or some specific host header or just a header in general that only allows your hard-coded value of your loader to actually reach that endpoint. And you basically give it some potential encryption keys. So because your loader is living on an infected system, it can do some host triaging, right? So it can, for example, get the internal domain name or get the internal IP address or the user that you're running under and use those as potential encryption keys. So then you would have what we call host-based keying, which would make your payloads that you're then going to reflectively load afterwards only be able to get decrypted or executed at that specific host, or at least make it harder for SOC analysts or other things like sandboxes to try and decrypt your payloads. So what you could potentially do is do some internal host triaging in your loader, so build some logic into there, and then make a web request to a web application that you basically design yourself with some endpoints there, like a RESTful API that basically says, okay, I want to have, for example, Rubius, please use this key, for example, the username that I'm running under as an encryption key. Then your endpoint could then fetch the latest Rubius source code from GitHub and compile it, and then do some obfuscation or potentially even encryption or both using the encryption keys that you provided. Then send it back to your loader and then have your loader brute force it, because your loader will have the potential keys already available to it. So it can, you don't have to hard code any keys here. You can just start brute forcing it using the internal triaging that you already did. So you have the knowledge of the internal IP address. You have that knowledge of that user that you're running under. You have the knowledge of, for example, the computer name. So those are all potential keys that you can use to encrypt and decrypt your binary. And then as a final step, just reflectively load that, brute force decrypt it, and execute it in a separate app domain. Once the execution is done, just unload that app domain and you're done. So that is a potential use case that you could do. Like, for example, if you have some additional research, if you have some dev experience, that's definitely a viable option there that you can potentially leverage using the building blocks that were provided in this workshop. Then what else can you do? Well, I actually gave you a nice hint here as well. So you have obfuscation, you have encryption, but you also have a thing called deception. So what is, like, can you spot what is going on in this picture? Can you see what could potentially bamboozle analysts? We've actually called our MC and ETW bypass MS-Corelib, and MS-Corelib is actually always loaded into a .NET assembly. So normally, of course, it will be backed on disk. Our specific case is reflectively loaded over the internet, so it's not backed on disk. But an inexperienced analyst could potentially be fooled here as well by just the naming. So you have encryption, you have obfuscation, but you have deception as well, which is something that I personally think is underutilized up until this point. It's primarily actually utilized by blue teams, like for example, having honeypot accounts that trigger. But from an offensive point of view, I think deception is not really that utilized yet. So it's something worth thinking about. And then some closing thoughts on tradecraft. So what I think the future of tradecraft will look like. So the basic scenario that I gave you about reflectively loading and using host triaging to get decryption keys and encryption keys, it's something that I didn't really invent. Some very smart people at MDSec came up with the covert toolsmith architecture. However, at this point in time, covert toolsmith is still not open sourced, even though Dominic, which is the CEO, repeatedly said that he was planning on open sourcing it, but his initial talk about covert toolsmith is probably already 1 or 2 years old now, and it's still not being done. So Dom, if you would happen to watch this, why are you not open sourcing this yet? So it's basically doing the thing I talked about in just like 2 slides ago about the host triaging and building the binaries, encrypting it, sending it back, doing the reflection kind of stuff. And then we have some potential other future stuff that we can talk about. And here you go, Rasta. I told you that I would mention you, so here you are. I think that C# is definitely here to stay. It's not going away anytime soon. The .NET framework is evolving though, so it's probably not going to be C# anymore as we know it, but it's probably going to transition to .NET Core, because by Windows 11, I guess that the standard .NET framework will be decommissioned, or at least that's what I think Microsoft stated. Correct me if I'm wrong here, Rasta. But I think that potentially new tradecraft will have to migrate to .NET Core, which has the additional benefit actually of being cross-platform, as .NET Core can potentially run on Linux systems as well. So there you go. And I think that other obscure languages, well, obscure, quote unquote, is going to be all the hype. So things like Rust, things like Nim, things like Boo, or things like Golang. Those are definitely languages that are worth picking up if you haven't done so already, because I think that we will definitely see some future tradecraft transitioning into those languages as more and more threat actors will start becoming aware of these languages as well, start developing tools in those languages in order to try and bypass EDRs. So there you go. That's it for the workshop. I hope you all had fun. I didn't do a who am I at the beginning. I'm doing a who am I at the end. So if you stuck with me for this long, allow me to introduce myself. So my name is Jean-François Maas. I'm the red team lead at Inviso's Aries branch, which is a Belgium cybersecurity firm. But I will be transitioning quite soon to Trusted Sec. So you'll probably catch me there starting from September. I'm also a SANS instructor, so I teach the SANS Sec 699, Purple Team Tactics, Adversary Emulation for Breach Prevention and Detection. So if you want to learn more about purple teaming or want to just hear more of my lame jokes, feel free to check that out as well. And you'll have all that good stuff about my Twitter, my LinkedIn, and my GitHub as well. If you want to connect with me, if you like this workshop, feel free to send out a tweet so I know that you liked it. Always nice to hear feedback, of course, always trying to improve. So thank you for your attention. And I think I will head over now to the Adversary voice channel. So if you have any more questions or if you just want to have a chat with me for the next 15 minutes, feel free to do so. I will be there. So thank you all for watching. Thank you all for sticking with me and doing the exercises. I hope you had fun. I had fun. So I hope to see you all again at a future talk or workshop or in person at a conference. Thank you all and hope to see you again very soon. Bye.